So we finished section 4.1 yesterday. 4.1 covered inverse trigonometric functions. So for inverse sine, inverse cosine, inverse tangent, we have to switch the inputs and outputs and find the angle that satisfies both the equation and our restriction. So we did some practice of that yesterday. Learning about inverse trig functions has prepared us to solve trigonometric equations. Okay, so let's go ahead and start in 4.2. Before we start the recording, let's check the audio. So please put the audio check in the chat, and if you haven't signed in, do so for attendance. Okay, very good.
Recording in progress.
This recording will cover section 4.2. Okay, so 4.2 is on basic sine, cosine, and tangent equations. 4.2, 4.3, 4.4 will take us through solving trigonometric equations. Okay. So to begin with, let's take a look at what they give us in the preview. Cosine of x is equal to -1. Okay, so let's start with Genesis. Looking at our unit circle, at what radian measure is cosine of x equal to -1?
Pi.
Correct. So right here at pi, the coordinates are -1, 0. Cosine is the x coordinate on the unit circle. So the x coordinate on the unit circle is -1 at pi. Okay. So that's one solution. Okay. However, any angle measure that's coterminal with pi, that would also be a solution. So Justin, can you give us another solution that would satisfy this equation?
3 pi,
Yes, and another one?
5 pi.
Good. So any radian measure coterminal with pi is going to be a solution. So pi, 3 pi, 5 pi, 7 pi, 9 pi, so forth. Okay. So
Can
this
it even
is
be like a negative too? Like it'd be like negative pi.
yes. Mm-hmm.
Okay.
Yeah. So negative pi would also be a solution, and there's many more. Okay, because we know that for any given angle, if we add or subtract one full rotation, we get a coterminal angle. So if we add or subtract 2 pi, we'll get coterminal angles. That also satisfies the equation. So this is a very important concept for us to understand before we go into solving trigonometric equations. I'll put that up here. When you take the inverse cosine, so we learned in 4.1, when you do inverse cosine, inputs and outputs switch. We want to take inverse trig functions come in handy when you're solving for the variable inside. To get it out, you use the inverse trig function. However, the inverse trig function, so if we put in inverse cosine of -1, remember the inverse trig function only gives you one solution, because to define it as a function, it has to generate exactly one output for every input. So inverse cosine only gives you the solution in the restriction, which means inverse cosine of -1, this is equal to just pi. Oops. Inverse cosine of -1 is pi. But cosine of x equals -1, there are infinitely many solutions. Okay, so I repeat, if they ask you to find the exact value of an inverse trig function, there's only one solution. But when solving trigonometric equations, solving for the input, there are infinitely many solutions to satisfy that equation. The inverse function is just the one solution that satisfies the equation and lives in the restriction. Okay. Another example of that is, if you remember in algebra class, we learned that, so if we had x squared equals 4, x could be plus or minus 2. However, if I asked you, what is the square root of 4? That's only positive 2. Because the square root only gives you one output. But this equation, x squared equals 4, gives you two solutions. So that's a similar concept. Okay. So we're going to go through one example together, and then we will list out the steps. It says, find all real numbers. I'm going to highlight the instructions that satisfy the equation. Okay. So actually, first, let's check. Are there any questions regarding the distinction between an inverse trig function and solving a trig equation? Inverse trig function only provides one solution to the equation. In solving a trig equation, we have to note there are infinitely many solutions to satisfy the equation. Okay, let me see if there are any questions in the chat. Okay, so let's move to example 1. There are 2 pre-steps before you start these problems. The pre-steps are, we need to determine, are they asking for specified solutions or all solutions? So circle, they want all solutions. And then from there, specify whether they want radians or degrees. All real numbers means we want radians. Okay, so those will be our seatbelt steps, where you have to do that before you start the problem. Identify the type of solution they want and whether your answer should be in radians or degrees. Okay, now we can start. So in solving a trigonometric equation, there are 3 steps. The first step is to isolate the trig function. Here, step 1 is already completed. Sometimes step 1 will take a lot of work, but for these level 1 problems, it's already isolated. Step 2, you're going to find the solutions between or in one period. So the period for sine and cosine is 2 pi. So you're going to find the solutions in one period. You can draw a circle if that helps you. It's not required. So if you want to sketch a little circle here and visualize, the x coordinate is 0. Let's see. X coordinate is 0 here and here. Okay. So x coordinate is 0 at, this is pi over 2 and 3 pi over 2. Okay. Step 3, you're going to add period times k to each solution because we know that the solutions will repeat every period. Okay, when you add a period, we know from the graph, period captures one cycle and then it repeats. So when you add period times k, you get all the angle measures that are coterminal that also satisfy the equation. So you add 2 pi k, add 2 pi k. Since the graph repeats every period, once you get the solutions in one period, you add period times k to generate all solutions. And then remember that we note k is any integer. In the software, it may say 2k pi. 2 pi k and 2k pi are the same. Okay, so those are the core 3 steps we're going to use to solve trigonometric equations. We'll write down the 3 steps, but first let's practice. So let me repeat. Step 1, we isolate the trig function. Step 2, we find the solutions in one period of the function. So here it would be one period for cosine is 0 to pi, or sorry, 0 to 2 pi. So from 0 to 2 pi, cosine of x is equal to -1/2. -1/2 is right here. So that's going to be at 2 pi over 3 and 4 pi over 3. Okay. 2 pi over 3 and 4 pi over 3. So your solutions, we have 2 pi over 3 and 4 pi over 3. However, those are just 2 of the solutions. We have infinitely many solutions. So step 3, we have to add period times k to each solution in order to generate all solutions. We know that solutions repeat every period. So we have to add, for cosine, the period is 2 pi. So we add 2 pi k to each solution. Okay, students, your turn to try part C. Send me a DM. Go through those 3 steps. Isolate the trig function. Find the solutions between 0 and 2 pi. And then box your answer with all solutions. Remember, k represents any integer. When you have all solutions, send me a DM. Justin, did you have a question? I think your mic is on. Okay.
No, I just forgot to turn it off.
Okay. So I was just taking a picture of the participant list so I can call on students. Okay, so let's take a couple more minutes and then we'll share. So I repeat the 3 steps. We are isolating the trig function, finding the solutions in one period of the function, and then generating all solutions by adding period times k to each solution. And the equations start level of difficulty easy, then it's going to progress as we work through this chapter. Okay, I'm seeing multiple correct answers in the DMs. Very good. Okay, let's hear from Stephanie. So, Stephanie, take us through part C. We want to isolate the trig function. So, what is cosine of x equal to?
It is equal to square root 3 over 2.
That's right. And then next step, we want to find the solutions between or in one period. So between 0 and 2 pi.
That would be pi over 6 and 11 pi over 6.
Yeah, so we know that root 3 over 2 is long leg. And when we draw that in our circle, so drawing the unit circle off to the side can help us visualize where our solutions are. And the two solutions between 0 and 2 pi are pi over 6 and 11 pi over 6. Okay, and then Stephanie, what is the last step?
It would be adding 2 pi k to each solution.
Yes. So for sine and cosine, where the period is 2 pi, adding the 2 pi k to each solution will generate all of the coterminal angles that are also solutions. Okay. Great. Thank you, Stephanie. Okay, so before I go to the steps, I want us to make a note here on page 1. In the instructions, when it says find all real numbers means they want x in radians. Okay. When they find all angles mean x in degrees. And the instructions will specify. So it'll specify whether to, if it just says find the exact value, that's in radians. Or find all real numbers, that's in radians. If it does want your answer in degrees, it would say express your answer in degrees. But in our textbook, when it says find all real numbers, that means they want the answer in radians. Find all angle measures, that means they want the x in degrees. Okay. So before we go through 1, 2, 3, there's actually the pre-steps. So the pre-steps, we need to determine, are we finding all solutions or specified solutions? Specified. And then degrees or radians. Okay. So before we go through the core 3 steps in solving a trig equation, we need to determine, are they asking for all solutions or specified solutions? And then should we express our answer in degrees or radians? So I call these the pre-steps before you start the problem. Okay. So once you have made a note of that, then you can go through the 3 steps here. Step 1, we want to isolate the trig function. And in these beginning level problems, that was a very easy step where it was already done for us. Sometimes it's going to take some algebra skills to isolate the trig function. So that's in purple. Step 2 is you want to find the solutions in one period of the trig function. I'll put solution or solution. Sometimes there's only one solution in the period. Other times there's more than one. And when you're working with sine, cosine, cosecant, secant, one period would be from 0 to 2 pi. When working with tangent and cotangent, one period is from 0 to pi. Okay. So we need to apply our graphing knowledge here. The first cycle for tan and cotan goes from 0 to pi. The first cycle for sine, cosine, cosecant, secant goes from 0 to 2 pi. So if you're working with tangent and cotangent, find the solution or solutions between 0 and pi. When working with sine, cosine, cosecant, and secant, find the solutions between 0 and 2 pi. Okay, and then step 3, we want to add period times k to each solution. Now that might not always be 2 pi k. If your period is 2 pi, then you're adding 2 pi k to each solution. But if your period is pi, then you add pi k to each solution. And sometimes we're in degrees, not radians, so it could be 360 degrees times k or 180 degrees times k. Okay, so those are the 3 central steps in solving a trig equation. Step 1, isolate trig function. Step 2, find the solutions in one period of the function. 0 to 2 pi for sine, cosine, cosecant, secant. 0 to pi for tangent, cotangent. And then step 3, we add period times k to each solution, which will give us all solutions. So this is to find all solutions. Okay, so page 1 is the basic problems. The level of difficulty will increase as we move along in this section and the next 2 sections. Okay, I'm pausing to see if there are any questions. If anything does not make sense to you, bring the question to the class discussion. Okay, very good. Let's turn to page 2. I'm going to call on students to help us solve these trig equations, and we'll have practice and reinforcement in 4.2, 4.3, 4.4. Okay. So let's start with the pre-steps. We want to identify, are they looking for all solutions or specified? So they're looking for all solutions here. And then all real numbers means that we are in radians. Those are the two pre-steps before you start the problem. Okay, so now we can go into the central 3 steps. Step 1, isolate the trig function. So let's start with Hector. Hector, when we get sine of x by itself, what is sine of x equal to?
It should be square root 2 over. I mean, negative square root 2 over 2.
That's right, because we do negative root 2 and then divide by 2. Yes. Thank you, Hector. Let's go to Jimmy. Jimmy, looking at our from 0 to 2 pi, what solutions, radian measures, satisfy the equation? Sine is the y-coordinate. Root 2 over 2 is in the twin group. Can someone step in for Jimmy? What are the solutions that satisfy the equation that are between 0 and 2 pi?
5 pi over 4 and 7 pi over 4.
Yes, I actually did not draw that correctly because I missed the negative sign. Good catch. Okay. So the y-coordinate is negative root 2 over 2. Negative is down here. Yes, at 5 pi over 4 and 7 pi over 4. There we go. Okay. Sine of x is negative root 2 over 2. This is a twin group. Sine is negative in quad 3 and 4. Drawing the circle helps you visualize what quadrant you're in. Sine is negative in quad 3 and 4. And then the reference angle is pi over 4. So in quad 3 and 4, that would be as Stephanie stated. Was that Stephanie?
Yes.
Thank you. 5 pi over 4 and 7 pi over 4. Great. And then the step 3 is to add period times k to each solution. Very good. So now we have all solutions that satisfy the initial equation. Okay. The next one, when we isolate our trig function, we get sine of x equals negative 3/5. Now, negative 3/5 is not on the unit circle. Okay, so let's make a note here for B. When you're given a when you isolate the trig function and you get a value that's not on the unit circle, or you know your solution is not one of the unit circle angle measures, then you need to use your calculator. Okay.
Professor,
Yes, go ahead.
why is it negative 3 over 5?
Oh, positive. I don't know why I'm mixing up the negative signs today. Thank you for checking that. It should just be 3 over 5. That is correct. Is that Hector?
Yes, Professor.
Hector, thank you. Good catch. Okay, but 3/5 is not one of the y coordinates on the unit circle. So when you isolate your trig function and you notice that your solution is not going to be on the unit circle, then you need to use your calculator. So let's make a note here. Not on unit circle. Then you must use calculator. And that's why we do the pre-step. The pre-step tells us whether we're in radian mode or degree mode. So use calculator and then make sure we're in radian mode. I think I mentioned this yesterday that for your upcoming exams, you'll be switching back and forth from radians to degrees. So you need to be prepared to do that in your calculator. Okay. So if your calculator right now is in radian mode, just type in R in the chat so I know you're ready to go. Radian mode would mean when you type in sine of pi, you get 0. So let me try that in mine. Sine of pi, I get 0, which confirms I'm in radian mode. So type in an R in the chat to indicate you're in radian mode. Great. Okay. So if it's not a unit circle value, let me put over here. Not a unit circle angle, then you need to use your calculator. So let's mark, where is sine 3/5? Remember, cosine is your x coordinate on the unit circle. Sine is your y coordinate on the unit circle. So this is y is here 1/5, 2/5, 3/5, 4/5, 5/5. So 3/5 is about here. Okay. Okay, but these are not on the unit circle. We know we have two solutions. We're going to call them x1 and x2. So if it's not on the unit circle, you use your calculator. And to find the first solution, x1, you use inverse sine. Because to solve for x, inputs and outputs switch, or you need to switch the inputs and outputs and introduce the inverse function. But remember, your inverse function is only going to give you one solution. So inverse sine gives you the solution between negative pi over 2 and pi over 2. Inverse sine is between negative pi over 2 and pi over 2. When you draw the circle, we have two solutions, one in quadrant 1, one in quadrant 2. Inverse sine will only give you the solution in quadrant 1. So inverse sine will give you x1. Okay. So in radian mode, students, share publicly, what do you get for x1? The first solution, it says round to the nearest 10th. Or actually, we don't want to round until the end, so just leave it out. Leave it out to more places, and then we'll round at the end. Share in the chat. When we type in, I'm seeing two different answers. Checking your calculator. You put in inverse sine of 3/5. Make sure that you're in radian mode. So when it's not on the unit circle, you need to use your calculator. To solve for the input, you introduce the inverse function, and inverse sine will give you one solution. Yes, okay. So it is 0.64350 ... If it's an intermediate step, you should take it out to more places. Let's just write out all the places. You can round your final answers, but do not round intermediate steps. So that's x1. Okay. Okay, so students, when we're taking a look at our circle, inverse sine only gives us one solution. To get x2, we need to use symmetry here. Okay, so I'm going to draw in, let's see if I can put in green here. This distance in green, right there. On our unit circle, that's going to be the 0.64, 0.64350111088. Because this is a radian measure. So that's the green distance. Okay. Due to the symmetry, on the other side, this is also the same distance. So any ideas how we can get x2? Given x1, now how can we find x2? Chime in through the chat.
Oh.
Or audio, yes. So inverse sine just gives us one solution, but looking at the circle, how can we figure out what the other solution is that's between 0 and 2 pi?
Do we just add a negative on sine x over 3/5?
No, if we took, let's say we took inverse sine of -3/5, that would give us the solutions down in quad 3 and 4. We don't want that. The inverse sine is only going to generate one solution. We have to look at the symmetry of the graph to help us find the other solutions.
Add pi.
Close. If we add pi, we're going to land down here. We don't want to be down in
Pi
quad.
over 2.
If we add pi over 2, we don't necessarily know the distance from x1 to x2 is pi over 2. We only know the green distances are the same. So halfway around the circle is pi. I'll give us a hint. How can we find x2? Excellent. That is correct. Very good. Okay. So due to the symmetry, once you get x1, we can see that x2 is going to be pi minus x1. And you'll note every time you're using inverse sine, to get the other solution that's between 0 and 2 pi, you have to do pi minus calculator answer to get the other solution. So calculator answer, that's x1. When working with inverse sine, or when working with an equation that includes sine, to find x2, you do pi minus x1. Okay. So let's do that. So in our calculator, we're going to do pi minus x1. That gives us the 2.498091545. So I'm writing out all the decimal places, because if we need to use a number to find another solution, we don't want to round prematurely. We only round our final answers. So now that we have the final answers, we can circle, we have 1 and 2. So now we have the final answers, we can round. That x is equal to, it says round to the nearest tenth. So 0.6, 2.5. Those are the two answers. Step 3 is adding period times k to each solution. So we still need to add 2 pi k to each solution to generate all solutions. Okay. Take a look at what we did here. Step 1, isolate the trig function. Step 2, find the solutions in one cycle. So for sine and cosine, that would be between 0 and 2 pi. If we can use our unit circle knowledge to do that, then that's the route we go. If it's not on the unit circle, then we're going to use our calculator, check the calculator mode. Calculator will give us one solution. Look on your circle to find the other solution. And then our step 3 is to add period times k to each solution. Okay. We said the period for sine and cosine is 2 pi. Therefore, in step 2, we were looking for the solutions between 0 and 2 pi. The period for tan and cotan is just pi. Thus, for tan and cotan, in step 2, we find the solutions between 0 and pi. Okay, so we're going to start with the pre-steps. We want all real numbers. So that means all solutions. And real numbers means that we're in radian mode. Those are the pre-steps. Then we're ready to go through the 3 central steps. Step 1, isolate trig function. Okay. Step 2, find the solutions in one period. So from 0 to pi. Okay, so from 0 to pi, tangent is root 3 over 3. Let's check that. Tangent is going to be root 3 over 3. That's going to be when your x coordinate is long leg and your y coordinate is short leg. Because when x is long leg, y is short leg, then that means that y over x, 1/2 over root 3 over 2, that simplifies to 1 over root 3, which is root 3 over 3. So this may take a little bit of side work, but we've determined at long leg, short leg is about here, right there. Okay. That's where tangent is going to be root 3 over 3. Okay. So that's pi over 6. There's only one solution between 0 and pi. And from there, we're going to add period times k. So add pi k to generate all solutions. The solutions will repeat every period. So after you get solutions in the first cycle of the function, you have to add period times k to generate all solutions. Okay. One more together. So let's see here. We have tan of x is equal to -7. So tangent of x is equal to -14. So far, step 1 has been very simple to isolate the trig function. Okay, so this is one that's not on the unit circle. Right away, we recognize not on unit circle. So we need to use calculator. And then we made a note that we're in radian mode. Okay, so you may be thinking we've been in radian mode the whole time, but again, on the exam, you're going to be switching, alternating back and forth. Okay, so if it's not on the unit circle, to find the first solution x1, you need to use the inverse trig function. Inverse trig function will give you one solution. Okay, so Jacob, do you remember what is the restriction for inverse tangent?
Is it 0 to pi?
No, so inverse cosine is between 0 and pi. Inverse sine is between -pi/2 and pi/2. How about inverse tan? Check your notes.
Oh, it's a -pi/2 and pi/2.
Yes. Exclusive. Okay. So let's find that and share in the public chat what you're getting for inverse tan of -14. And we do want to place it on the circle. Okay, yes, good. So we don't want to round prematurely. Great. Okay, so let's talk about this. This is going to be, oops, where did it go? Negative 1.499488862. Okay. In order to get a final answer here, we're going to have to check the instructions very carefully in the software. Okay, so if we put in our calculator, negative pi over 2, right here, that's at about negative 1.57. So our solution x1 is about here. So I'll mark that x1. And this is what we got from the calculator. Inverse tan right here. Okay. However, usually it does ask to give the first solution should be non-negative. So let's see here. To get the solution between 0 and 2 pi, or actually now we want the solution between 0 and pi, all we need to do is to add one period. So if we add one period, so to get another solution, we're going to take x1 plus pi, because x1, that's negative 1.49. When you add a period, so remember, positive angles go counterclockwise. When you add a period, you're going to land here between 0 and 2 pi. Okay. Okay, so we want to add a period. And x2 comes out. Let's see, so we take our calculator answer, add a period, and now we get the solution between 0 and pi. It's 1.642103792. So that's the answer between 0 and pi. We only have one solution between 0 and pi. So this is the only solution between 0 and pi. I'll circle that. And now we're going to round to the nearest tenth, 1.6. Add period times k, so plus pi k. You don't have to list the other one because tangent, the period goes, the first cycle goes from 0 to pi. So from 0 to pi, you're only going to get one solution. And then you add pi k to that solution. So if you answered x is equal to negative 1.5 plus pi k, this is equivalent, but the software might mark it wrong if it specifies it wants the first answer as non-negative. So the first answer should be the one when you're working with tangent between 0 and pi. When working with sine and cosine, your first answers are between 0 and 2 pi. So the first cycle of the function. And then you add period times k to each solution. K can be positive or negative. So when you add period times k, it generates all solutions in both directions. Okay, so that's why we don't want the second line here. Are there any questions with what we've learned so far? We have seen problems that include sine, cosine, and tangent. Hector, yes, I see you raise your hand.
Where did you get negative 1.57 on the graph?
Oh, yes, very good question. So that was just to help me locate where the negative 1.49 is, because I put in negative pi over 2 is approximately negative 1.57. So since I know that so at the negative y-axis, we're at negative pi over 2. That's negative 1.57. That was to help me draw in. I know my x1 ended up being very close to negative 1.5. So that helped me locate where x1 was.
Okay, got it. Thank you.
Yes.
I had a question.
Yes.
If x1 was not negative, would you still have to add pi to it to find the x2 value?
No, you're just, so going back here, for sine, cosine, cosecant, secant, you want to find the solutions between 0 and 2 pi. For tangent and cotangent, you want to find the solutions between 0 and pi. Once you've done that, you're done with step 2. Sometimes it involves adding, subtracting, other times it doesn't. So it just depends on what you're given.
Okay, thank you.
In general, when you're working with sine, cosine, cosecant, secant, calculator is going to give you one solution. You have to look at the symmetry to get the other one. When working with tan and cotan, if the calculator gives you the positive solution, you're fine. If they give you the negative solution, you just add pi to get the one between 0 and pi. That's why I like to draw these mini circles off to the side to see where's my solution and do I need to make any adjustments to find the solution either between 0 and 2 pi or between 0 and pi. Okay, so you'll remember that in the pre-steps we said, note whether it's asking for all solutions or specified solutions. If it is asking for specified solutions, you still want to go through all 3 steps. But then your final answer is only going to be the solutions in the interval they asked for. But to get solutions in the interval they asked for, you still want to generate all solutions first and then find the solutions in the specified interval. Okay. And then if they want the answer in degrees, make sure that your solutions are in degrees.
So Professor, the last example we did, was that a specified solution?
No, so far we've just been getting all solutions. All solutions meaning that after we go through the 3 steps, that completes. So when you go through the 3-step process, it generates all solutions. So do you see all the examples we did? We end up having plus 2 pi k or plus pi k.
Yeah.
So that means we have all solutions. In step 2, we need to find the solutions either between 0 and 2 pi or between 0 and pi. But once we complete step 3, that gives us all solutions. Hector, does that make sense?
Yes.
Adding that pi k, yes. Okay.
Yes.
Great. So the next page you're going to try on your own or actually discuss in the breakout rooms. So try in groups. We have 3 problems, and I'm going to just double star the entire page because these are the types of problems, level of difficulty, you'll be seeing for the 4.2. Homework, quiz, and exams. Okay. So in a moment, we're going to go into the 2 breakout rooms and you're going to work on these 3 problems together. Remember the 2 pre-steps. Determine if you want all solutions or specified solutions. Determine if your answers are in degrees or radians. And then from there, you follow the 3-step process to generate all solutions. If they want specified solutions, then you can just find the answers in the specified intervals. But you still need to go through the full 3 steps to solve the equation. Okay, if we're ready to go in the rooms, just type in R for ready. If you have more questions, let me know. I'm gonna pause the recording.
Recording stopped.
So the R indicates that you're ready to go in the breakout rooms. Okay, and if there's something you want to discuss with me individually, stay in the main session. Otherwise, go ahead and join your groups at this time. You're working on these 3 problems.
So for the first one, should we break it up into like 2 different equations? Like change 3 cosine plus square root of 12 into cosine equals negative square root of 12 divided by 3.
I just did it like a normal I just subtracted negative square root from the left side, and then I subtracted the cosine alpha on the right side. So then I got 2 cosine alpha equals square root of 3 minus square root of 12, which is square root of 12 is actually 2 square root 3. So that simplifies down to just square root of 3. And then I divided the 2 on the other side. So then I got cosine alpha equals square root 3 over 2. And then the two answers I got was pi over 6 and 11 pi over 6. But since the restrictions are between negative 360 and 360, all I did was pi over 6 minus 2 pi and 11 pi over 6 minus 2 pi. There's no k because there's a restriction. It's only one revolution.
Did you say you got cosine squared in there?
No, it's 2 cosine. The 2 is in
Okay.
front of the cosine. Because if you subtract the cosine from the right side to the left side, the left side is now 2 cosine alpha, not cosine squared. The 2's in front. And then I subtracted the square root 12, which is actually 2 square root 3. And then that simplifies down to square root of 3. And then I divided the 2 from the left side to the right side, which makes it cosine alpha equals square root 3 over 2. And then that's true in two areas, pi over 6 and 11 pi over 6. And then since the restriction is negative 360 to 360, I just did subtract 360. Or I mean, I subtract 2 pi, which is 360 from each of those two answers. Because technically there would only be 4 answers because of the restrictions. What's up? I got pi over 6, and then I got 11 pi over 6. And then because of the restrictions, I just did minus 2 pi from pi over 6, and then minus 2 pi from 11 pi over 6. Well, technically, I think you can just list them, right? I don't think I have to put like the equation because there's restrictions. So then the answer, I guess the answers would be negative 11 pi over 6 and negative pi over 6. And then pi over 6 and 11 pi over 6. Yeah, because this one's not asking for all real numbers. It's just asking between negative 360 and 360. Mm, probably. So convert it. So pi over 6 times 180 over pi. So it's 30. So it's 30 degrees, 330 degrees, and then negative 30 degrees, and then negative 330 degrees. Good catch. Mm-hmm.
Simplify the first one down to just 5 pi over 6 minus 2 pi, and then 7 pi over 6 minus 2 pi to get the negative ones.
For the first one,
Yeah,
what'd you get?
because we have like there's 4
Yeah,
values,
but
right?
those would be negative values, though. The
That's why I
ones
said
you're
you can just subtract 2 pi.
I know, but the original one is a positive, isn't it? Let me see.
I mean, yeah,
It's a positive 3 square root 3 over 2. So then it would be the positive values.
okay.
So it'd be but then from that you can just subtract pi or 2 pi. Yeah.
Yeah,
But then like Michael said that it has to be in degrees modes because the restrictions specify degrees.
right.
Hi, students in group 1. How are we doing? Any questions to help guide you with the solutions?
For number 2, um I just multiplied 552.9 to the other side, and then I used my calculator, and then I took the inverse, but that doesn't lie within the restrictions. Am I doing something wrong?
That's a good question. So let's see. For this particular problem, oh yes, it doesn't, because it's just going to give you an answer between negative 90 degrees and 90 degrees.
Mm-hmm.
And so you have to draw the circle and use the symmetry to help you find the solution in the restriction, or
Okay.
inverse sine just gives you one solution, but to get other solutions, you look at the circle.
Okay, thank you.
And students, did you have any questions with the first one? Okay, so were we able to recognize square root of 12 is actually 2 root 3? The first one shouldn't require a calculator because the value is on the unit circle.
What was it supposed to be?
So square root of 12 is 2 times square root of 3.
Oh, sorry. Yeah. I got
We
that. I
got
thought
that.
you were
Okay.
talking about that. Okay, thank you.
And then let's see. Yeah, just in general with these problems that you're using a calculator, write out all the places until you get to the end, then you can round. Now, sometimes if you round in between, it doesn't make a difference, but just to be safe, you don't want your answer to have rounding differences, so just leave out all the places or leave it in exact form until you get to the end. Okay, and then students, as you're working through these problems, if you have questions, just put the ask for help question mark, and that will send me a message so I can come in back to the room. Okay, great.
Hey, have you finished with number 2 yet? Well, what I did first was I got the denominator out of the right side, so I multiplied 52.9 to both sides, and then I just used my calculator to get the left side, which is 52.9 times sine 9.7 degrees over 15.4, and I got 0.57877196, and then I took the inverse of that, and I got 35.36421512 degrees. But that doesn't lie in the restrictions, so I'm trying to figure out, like, should I just go like how she did and then go left and then down?
Wait, did you just multiply 52.9 to 7? I mean sine?
Yeah, I multiplied it to the other. I did 52.9 times sine on the left side divided by 15.4.
Okay, because I did, so basically I just did sine 9.7, figured out that, and then divided that by 15.4, and then I multiplied that answer by 52.9, and I got 0.578771.
Yeah, it's the same answer I got.
Okay.
You just did it a different way.
Yeah.
And then I took the inverse of that, and then that's when I got 35.3642, but it doesn't lie in the restrictions, so I'm trying to figure out, like, what do I subtract?
All right. So
She did it earlier, but I wasn't paying attention.
between 90 and 180.
So technically the restrictions are to the left or to the second quadrant. So what should like how you did it, Michael, or Miguel, where you did it, subtract pi when it was tangent, when she was doing it like an example. Well, the restrictions is the second quadrant. So, but the answer I got when I did my inverse was 35 degrees, 35.36. But I remember on an earlier example, she was asking how we get the second value. Okay, sweet. So then it would be 54.6 degrees. I guess the answer would be. Then that would satisfy the restrictions. You know, I'm just gonna plug it in, see if it comes out to the same. Zero, nine, 10, 0, 9, 5, 4, 7. Oops. No, it doesn't come out to the same answer as the left side.
Wait, when you did you add pi or subtract pi?
Subtract pi, or subtract pi, or pi minus the answer we got for the inverse.
Did you do it in pi or did you do 180? Because I think that's the problem.
I did a 9. Oh wait, no, well, it would be in quadrant 2, so I did I subtracted so
Should
oh
be
no,
the
it'd be plus 90, huh?
quadrant
did it.
is 180, no?
Yeah, well, quadrant 2 is 180 to 90. So you're right, Hector. Juan, it's plus 90. That's why I'm getting it wrong. So then the answer would be 125.364 degrees. I'm just gonna plug it in. That's what I was trying to see if it's right. Because if you plug it in, both sides should equal the same. No, it still doesn't come out to the same answer. She doesn't let us go back.
Okay, we're still waiting on a couple students. Okay, looks like everyone is back in the breakout rooms, or sorry, back from the breakout rooms in the main session. So we are going to go through the full solutions for these 3 problems and finish up 4.2 after the break. However, before we go to break, I want to remind us that our exam 2 coming up next Thursday covers 2.3, 2.4, all of chapter 3, and then 4.1, 4.2. So we're going to be finishing the exam 2 coverage material today, and then you'll have the long weekend and next week to prep for exam 2, which will be next Thursday. Because in chapter 2 and 3, we have graphing and identity proofs, our exam 2 is going to be fully free response. Okay. Let's go ahead and take a break, come back at 9:40, and then at 9:40, we will go through the full solutions for these 3 problems. So come back at 9:40. So students, we're on break now. Be back at 9:40. Okay, students, let's put a B for back. We're going to come together to go through the 3 solutions here. If you can hear me and you're ready to continue, please type in a B for back. And also, if you were able to get through these 3 problems, send me a DM with your answers so I can see where we are in solving these trig equations. So B for back and then DM your answers. We'll be going through the full solution for all 3 problems. Okay, so let's see here. Miguel, Genesis, Stephanie, Justin, Jacob, Khalid. Students, if you are back from the break, please put in a B for back. Okay, see Juan and Esmeralda. Send me a DM with what your answers are from the group work. Okay, I'll give us a couple minutes to send in your answers. Okay, let's go ahead and resume the recording.
Recording in progress.
Okay, so students, we're going to go through the full solutions here. From what I've seen so far in the private chat, some answers are on track. There are some careless errors that I'm observing as well. So for number 1, I saw some answers in radians. Remember, the pre-steps will tell us whether we're in degrees or radians, whether we want specified solutions or all solutions. So to begin with, we notice here, it only wants the solution between negative 360 and 360 degrees. Make note of that. And then also, it's asking you to find alpha between negative 360 degrees and 360 degrees, which means that we're in degrees, not radians. Okay, so specified solutions in degrees. Now we're ready to go through the central 3-step process for solving trigonometric equations. So this problem, I would recommend the apple banana method to help us isolate the trig function. Okay. So to help us isolate cosine of alpha, we can let cosine of alpha equal a for apple. And we have here 3a plus root 12 is equal to a plus root 3. Okay. Okay, so let's get our variable on one side. Subtract a from both sides. Now we have 2a. We can rewrite root 12 as 2 root 3 because 12 is 4 times 3. So square root of 4 is 2. Square root of 3 stays. Okay. So we have 2 apple is equal to, this is 1 root 3 minus 2 root 3, so negative root 3. Apple comes out to be negative root 3 over 2. Okay, so to fit it in, I'm going to have to shrink a little. And apple represented cosine of alpha. So cosine of alpha is negative root 3 over 2. We finished step 1. On to step 2. So for step 2, we're going to draw out our circle. We know that the period for sine and cosine is 2 pi. But since we're in degrees, that's going to be 360 degrees. So period in degrees is 360 degrees. Okay, so moving on to step 2. Let's bring students into the discussion. So let's hear from Juan. Juan, on our unit circle between 0 and 360 degrees, at what degree measures is cosine of alpha equal to negative root 3 over 2? Let's hear from Juan. Okay, not hearing from Juan. How about Jacob? So Jacob, between 0 and 360 degrees, at what angle measures is cosine of alpha equal to negative root 3 over 2?
Be 150 and 210.
That's right. Because cosine is negative in quad 2 and 3. Cosine is long leg at the reference angle 30 degrees. So reference angle 30 degrees, but we're in quad 2 and 3. So that's 150 degrees and 210 degrees. If you had answered 5 pi over 6 and 7 pi over 6, that would be the correct answer in radians, but not in degrees. So it'd be marked wrong. Okay, and then the third step is adding period times k to each solution. So if you were adding 2 pi k, that's not correct because we're in degrees. So we should be adding 360 degrees times k to each solution. Okay, so this is all solutions. So this is our 3-step process. First step, purple, isolate trig function. Second step, draw the circle to find the solutions in the first cycle of the function. And then third step is add period times k to each solution. So we've gone through the 3 steps. Now, to get the specified solutions, we look to see our answer will be between negative 360 and positive 360. That's when k is negative 1 and when k is 0. Okay, so when k is negative 1, see, when k is negative 1, we do 150 minus 360, 210 minus 360. So that's going to be negative 210 degrees and negative 150 degrees. When k is 0, our solutions are 150 and 210. Okay, so assigning the k values to be negative 1 and 0, we end up with the solutions in the specified interval. Alpha is, let's put it in order, negative 210 degrees, negative 150 degrees, positive 150 degrees, and positive 210 degrees. So if they do ask for specified solutions, after you finish the 3-step process, you have to find the solutions in the specified interval, and that's your final answer. Okay. If we're good with number 1, just type in 1, meaning we either got the same solution or we understand the solution, and we're ready to move to number 2. So I think a common error that I saw is students isolated cosine of alpha and maybe got root 3 over 2 was missing the negative sign. The reason why we have negative is because 1 root 3 minus 2 root 3, 1 banana minus 2 bananas, we have negative banana. 1 minus 2 is negative 1. So that's why cosine of alpha ends up being negative root 3 over 2. So alpha is either 150 degrees or 210 degrees plus period times k to each solution. Okay. I don't see any questions, which means we're ready to move forward. Okay, so let's hear from Genesis. Genesis, how do we isolate the trig function sine of beta?
You can multiply the right side by 52.9 and the left side.
Yes, okay. So, well, actually, first let's indicate we want specified solutions and we're in degrees. So those are the two pre-steps. This one, we can just multiply both sides by 52.9. So sine of beta is 52.9 times sine of 9.7 degrees over 15.4. We also could have cross multiplied to isolate sine of beta. When you have fraction equals a fraction, you can set diagonal products equal to each other to help you solve. Okay, but this one we just saw multiply the 52.9 to both sides. That allows you to isolate sine of beta. Okay. So once you have the trig function by itself, then you assess, we want to find the solutions between 0 and 2 pi. This time, clearly, we're not on the unit circle. Okay, so when we're not on the unit circle, to get beta 1, we have to use inverse sine. And we must be in degree mode here because the input is given in degrees. So this is where we have to switch our calculator from degree mode to radian mode. Okay, so remember that inverse sine is between negative pi over 2 and pi over 2. Or in degrees, that would be negative 90 degrees and 90 degrees. So it's not going to give you the answer in the specified solution. But we can use that answer to help us get the other answer between 0 and 360 degrees. Okay. So inverse sine is between negative 90 degrees and 90 degrees. When you put this expression into your calculator, so first make sure you're in degree mode. 52.9 times sine of 9.7 divided by 15.4, that's approximately 0.58. So getting that approximation will help you draw. It's approximately 0.58. Sine is the y coordinate. So we're about here. Okay. Okay, so the calculator is going to give you beta 1. And then from there, we need to be able to figure out beta 2. Okay, so type in the public chat, what are you getting for beta 1? Inverse sine will give you the solution between negative 90 degrees and 90 degrees. So you put inverse sine of that expression. You want to make sure you're in degree mode. And let's share in the public chat what we're getting for beta 1. Beta 1 is going to be the answer in the restriction for inverse sine. Okay, I see we're in agreement. 35 points. This is not a final answer, so let's take it out. 3642151 degrees. So I will do the light circle since it's not a final answer. It is one solution between 0 and 360 degrees. But remember, to get the other solution, we have to look at the symmetry. So beta 1, this time since it's not radians, maybe I should put in here. Beta 1 here gives you, this is about 35 degrees. So beta 2 is going to be 180 minus beta 1. You can see from the symmetry of the graph, beta 2 is 180 degrees minus beta 1. Okay, so let's do that in our calculator. Beta 2 is 180 degrees minus beta 1, or actually we'll just put equals here. 180 minus beta 1 should be 144.6357849 degrees. Okay. So just for practice here, if they ask for all solutions, after you get the solutions between 0 and 360 degrees, you add, so we're going to round to the nearest 10th. It doesn't specify, but we'll just follow to the nearest 10th. In MyStatLab, it will always specify rounding. Okay, so step 3, you add period times k to each solution. In degrees, we're adding 360 degrees times k to each solution. So this is going to generate all solutions. Okay. However, we only want to report the solution in quadrant 2. So the solution in quadrant 2 is 144.6 degrees. Okay, so it's really going to help you to get into a habit of reporting all solutions first and then finding the solutions in the interval they give you. You may not see why we're doing that here, but later on, that's going to be a good strategy for us to follow. So I'll repeat that. For both 1 and 2, we did the pre-step. We identified they want specified solutions and we're in degrees. Then from there, we followed the central 3-step process to solve trig equations. Step 1, isolate trig function. Step 2, find the solutions in the first cycle of the function. Step 3, we add period times k to each solution. So that will give us all solutions to the trigonometric equation. Then if we want specified solutions, we just report the solutions in the region they give us. Let's type in 2 if we're good with number 2, ready to move on to number 3. One, two, three, oops. Okay. Okay, so for this one to get, or actually, I need to remind myself the pre-steps. So before we even look at the equation, we identify. We want specified solutions, and this time we're in radians. Get into a habit of doing that before you even touch the problem. Okay. So now we want to isolate the trig function. That's our first step. We're ready for the 3-step process. So 6.8 squared, that's 46.24. 3.2 squared is 10.24. 4.6 squared, 21.16. 2 times 3.2 times 4.6, that's 29.44. We have cosine of theta. So these two problems are getting us ready for chapter 5 when we apply law of sines and law of cosines. But it is a chapter 4 problem, 4.2 problem, because we're asked to solve for the angle. So solving trigonometric equations requires our chapter 4 skills. Step 1, isolate the trig function. Okay, so let's go ahead and combine like terms here. Use our algebra skills, combine like terms. We want to get the constants on one side. And then we're solving for cosine of theta. So we want to isolate cosine of theta. Okay, so at this step, Miguel, what should we do to both sides to get cosine of theta by itself? Let's hear from Miguel. Yes, we divide both sides by the negative 29.44 to isolate cosine of theta. That's right. So whatever is attached to cosine of theta, divide that out. And now we have isolated cosine of theta. Okay. So cosine of theta is now by itself. This is step 1. Step 2, we want to find the solutions between 0 and 2 pi. So let's draw here. Okay. Okay, so this portion right here is approximately 0.5. So cosine right here is approximately 0.5 here and here. It's not on the unit circle, so we need to use inverse. So you do inverse cosine of negative 14.84 over 29.44. Okay. So the calculator gives us the solution in the restriction. So inverse cosine is between 0 and pi. Inverse cosine is between 0 and pi. So your calculator will give you the solution between 0 and pi. To get the other solution in quadrant 4, now we need to look at our graph. Okay. So Stephanie, any ideas? How can we get theta 2 this time? When working with sine, to get theta 2, we do pi minus theta 1. When working with cosine, to get theta 2, what should we do? Let's hear from Stephanie.
Would we add pi?
Not quite. If we add pi, we land in quad 3. Okay, so let's share first. Theta 1. Let's see what theta 1 is. Oh, did I place it on the wrong side? I think I did that again. Students, let me fix this. Because we have to be able to see the symmetry in order to answer that question. So cosine of theta is approximately -1/2. Should be on this side. It's not exactly -1/2, so it's not on the unit circle. But theta 1 is going to be the answer between 0 and pi. So let me open it up to the class. How can we find theta 2? So theta 1 is this green distance here. Given this green distance, how can we find theta 2? Any suggestions?
Subtract 270?
Not quite. Remember, we're in radians. If we did 180 or pi minus theta 1, that wouldn't land us in quadrant 3. So first, let's get the answer for theta 1. So let's put that in our calculator. Okay. And we need to switch over to radian mode. So students, switch over to radian mode. Report, what are you getting for theta 1? It's not your final answer, so you want to leave out all the decimal places. So let's report it. What are we getting for theta 1?
Professor, would we subtract that the theta prime or 1 minus pi, and then that answer we would add it to pi to get theta 2?
That could work. Let's talk about that. Was that Justin?
Yes.
Good suggestion. Let's discuss. First, Jimmy, I just saw your message. Do you need to leave now? Okay. Yes. So, Jimmy, let's follow up through email. Just send me an email and I'll respond to that. Take care of yourself. Okay. You too. Okay, students. So, Justin's very creative method is saying that this distance here, if we do, well, we're in radians this time. So pi minus theta 1, we get that distance. And then if we do pi plus that distance, we'll land on theta 2. That would work. That's correct. A more direct method, though, would just be to take 2 pi minus the green distance. So the green distance or symmetry. Do we see that? So let me remove that to show us. 2 pi minus green will land on theta 2. Okay, so Justin's method works. A more direct approach, though, would just be to get theta 2, to do 2 pi minus theta 1. And in general, we can remember when working with sine, you do pi minus first to get second. When working with cosine, you do 2 pi minus first to get second. I'm going to summarize that at the end. So we can see from the graph, if we do 2 pi minus the green distance, we'll end up with theta 2. Okay, so let's try that. 2 pi minus green distance. That gives us 4.184077115. And we're in radians, so we end up with, these are two solutions between 0 and 2 pi. Okay, so we have rounded to the nearest tenth. This would be 2.1 and 4.2. Then we add 2 pi k to each solution. If we were in degrees, we'd be adding 360 degrees times k to each solution. But since we're in radians, we're adding 2 pi k to each solution. Okay. So this gives us all solutions. Get into a habit of completing the full 3 steps. We did the pre-steps, then step 1, step 2, step 3. Now, if they only want solutions between 0 and 2 pi, then we can answer between 0 and 2 pi. That would be 2.1 and 4.2. Remember, between 0 and 2 pi, that's between 0 and approximately 6.28. Because pi is about 3.14, so 2 pi is about 6.28. So if they want solutions between 0 and 2 pi, it's between 0 and approximately 6.28. Okay, if we're good with number 3, now let's type in 3. I think from what I saw in the chat, we were on track. Maybe some things that we need to check. Okay, so in case you want to get a screenshot with all 3, let me see if I can put it. Yes. So for each of these problems, we identified, it was specified solutions, and then we identified degrees or radians. Then we went through the central 3 steps. Isolate the trig function, find the solutions in one cycle, first cycle of the function, and then add period times k to each solution to generate all solutions. From there, we found the solutions in the interval they specified to finish our solution or finish the problem. Okay. Let's see if we are ready to move forward. 1, 2, 3. Okay, not everyone responded. If we're not good with 3, what questions do we have? Okay, I see. Very good. Okay, time to go to the last page to finish up section 4.2. As a college algebra student, we learn how to find inverse functions. Step 1, we switched x and y, switch or interchange x and y. And then you want to solve for the new y. These were the steps that we took to find the inverse function as an algebra student. Okay, so let's do that here. We have y is equal to 5 sine of 3x. Okay. So first find the inverse function. We're going to follow these 2 steps. Step 1, we do the switch. We switch x and y. This is step 1. Step 2, we want to solve for y. So let's isolate y. Okay, so to isolate y, we're going to divide both sides by 5. Remember, when we want to solve for something that's stuck inside. I say when it's stuck inside, to get it outside, we have to introduce the inverse function. So to bring the input outside, we go from sine to inverse sine, and that allows us to switch. Oops. Going from sine to inverse sine allows us to switch. So the x over 5 comes in. and the 3y goes out. Okay, so finally we want to isolate y. So let's divide both sides by 3. So this is our new y. Okay. So that means that our inverse function, which we use the notation f of x inverse, or inverse f of x, we insert that -1 symbol there. That's not for the exponent, that's an inverse symbol. So the inverse function is 1/3 inverse sine of x over 5. To find that inverse function, we switch the x and y's and solved for the new y. And now we have our inverse function. Okay, so let's see if we can get the domain and range. I'm going to call on students to help. First, let's get the domain and range for f of x. Then we can switch them to get the domain and range for f inverse. So they tell us in the problem for f of x, the domain goes from -π/6 to π/6 because they tell us the function exists for x values in between -π/6 and π/6. Using our chapter 2 skills, let's figure out the range. Okay. Okay. Let's see. We haven't heard from Esmeralda. Esmeralda, I know your mic isn't working, but in the chat, can you tell us what is the range for y equals sine of x? What is our range for y equals sine of x? So Esmeralda, please respond in the chat. That's right. Okay. We're going to Hector next. Hector, I think your mic is working, so please unmute. For our function, what transformations do we have? So what does that 5 do? When we multiply sine by 5, how does that transform our graph?
I'm not sure, Professor.
Okay, let's check with the class. How does multiplying sine of x by 5 affect the graph? So is it vertical stretch, horizontal stretch, or is it shifting up, down, left, right? How does it transform the graph when you multiply by 5?
It's a vertical stretch.
That's right. It's a vertical stretch by a factor of 5. Okay. Now this 3, oops, I'll put here, the b value being 3, that just tells us the period is going to be 2 pi over 3. Okay. But the period doesn't affect the range. So it just tells us one cycle of the graph is completed in 2 pi over 3, but it doesn't affect the range. The vertical stretch by a factor of 5 does affect the range. So if we take our original parent function, change the period to 2 pi over 3, and then vertically stretch it by a factor of 5, now for f of x, vertical stretch by a factor of 5, the range would be -5 to 5. The period doesn't affect the range. So period 2 pi over 3 does not affect range. But the vertical stretch by a factor of 5 does. And with the vertical shift by a factor of 5, the range for f of x is -5 to 5. Okay. Let's go to Jacob. So Jacob, if we know the domain and range for f of x, how do we get the domain and range for f inverse? Jacob, I think you're still on mute.
We just have to, what's it called? Do 2 pi over b, and in this case, isn't b 1 over 5?
And no, the 2 pi over b is to get the period. The b value is 3. So 2 pi over 3 gives us the period of our function. But remember, the theme for inverse is inputs and outputs switch. So if the inputs and outputs switch, that means the domain and range also switches when you go from f to f inverse.
Right, okay.
So if the domain and range switch, that means for f inverse, the domain for f inverse is the range for f of x. So the domain for f inverse will be -5 to 5. And then the range for f inverse is the domain for f. So that's going to be -pi over 6 to pi over 6. Jacob, are we good with that?
Yeah, sorry, I got lost.
Okay. Yes. So when we are discussing inverse, inverse means inputs and outputs switch. Therefore, the domain and range of f, or when for the domain and range for f inverse is going to be range and domain for f. That means domain for f inverse is range for f. Range for f inverse is domain for f. They switch. Okay, take a look at what we did here to see if you have any questions. And then we have some summary notes to wrap up section 4.2. Okay, I'm not seeing any questions. Okay, so to reinforce what we did here, when we are given a trigonometric equation, we first determine if they're asking for all solutions or specified solutions, and if we're in degrees or radians. So make note of that before you start the problem. Then step 1, you're going to isolate the trig function. Step 2, find the solutions in one cycle, the first cycle of your function. And step 3, add period times k to each solution. Once you complete those 3 steps, then if you're given a specified interval, you find the answers in that specified interval. Okay. Now, if the answers are on the unit circle, students will be expected to give the exact answer, radians or degrees, that are on the circle. However, if it's not on the unit circle, let's put in some notes here. So, not on unit circle for sine. To get the first solution, you use inverse sine. Okay, and then let's draw a picture here. The first solution will be in the restriction. So let's say this is theta 1. That's your first solution. To get the second solution, you're going to have to do either pi or 180 degrees minus the first solution to get the second solution. Okay. So for sine, inverse sine will give you the first solution. If you do pi or 180 degrees minus the first solution, then you'll get the second solution. Pi if you're in radians, 180 degrees if you're in degrees.
So professor, for the second one, should it be 2? You put 1 on both sides.
Oh, this one, yes, this one should say 2. Good observation. Theta 1 is the one that inverse sine gives us that's in the restriction for inverse sine. And then to get theta 2, you do either pi or 180 degrees minus theta 1 to get theta 2. Thank you, Hector. It's because of the symmetry. So theta 1 is this distance. To get theta 2, you have to do either pi or 180 degrees minus the green distance to get theta 2. Okay. When we're working with cosine, to get the first solution, you do inverse cosine. Okay, let's draw the circle. Okay, so let's say the first solution is here, theta 1. Let's go down. So remember, sine, these solutions share the same y coordinates, or these inputs share the same y coordinate. And then for cosine, these inputs share the same x coordinate. Because cosine is the x coordinate on the unit circle, sine is the y coordinate on the unit circle. Inverse cosine gives you the solution between 0 and pi. So in this restriction, to get theta 2, you have to do 2 pi or 360 degrees minus theta 1 to get theta 2. So that's just due to the symmetry that when you're working with sine, do pi or 180 degrees minus first solution to get second solution. When working with cosine, you do 2 pi or 360 degrees minus first solution to get second solution. Okay. So yes, go ahead. Not 0 and 90. Theta 1 will be between negative 90 and positive 90, or negative pi over 2 and positive pi over 2. It's in the restriction. But even if you get, let's say theta 1, okay. So even if theta 1 is a negative value, when you do pi or 180 degrees minus that negative, when you're subtracting a negative, you'll get positive, and you'll get the answer in quad 3. We'll take a look at that when we move forward, but this formula applies no matter whether your answer is positive or negative. To get the second solution, when working with sine, you always do pi or 180 degrees minus first. To get the second solution when working with cosine, we always can take 2 pi or 360 degrees minus the first. So this should say first.
Okay, there you go.
Yes, thank you. So these formulas apply for any time you're working with sine or cosine, and you have values that are not on the unit circle, meaning your theta values are not going to be degrees or radian measures that are on our unit circle. Okay, thank you for those corrections. I know I've been switching the ones and twos. So take a screenshot of this if needed. The inverse trig function gives you the first solution. Then when working with sine, you do pi or 180 degrees minus first to get second. When working with cosine, you do 2 pi or 360 degrees minus first to get second. Okay, so this concludes the section 4.2 recording. Let me stop that here.